Hi friends, this is PH4501 lattice vibration lecture number 6 by Dr. M.R. Gadhvi. In the previous lecture, we have calculated and derived the theory for the diatomic lattice vibration in a one-dimensional. Now, in this case, we have seen the totally contrast behavior context to the monoatomic lattice vibrations. In monolattice atomic vibrations, there is only acoustic branch, whereas in case of the diatomic, we having a chance to observe a two kind of the branch, acoustic branch and the optical branch. Acoustic branch is always with a little bit lower range of a frequency, whereas the optical branch is little bit with the higher range of a frequency. If you have observed in the dispersive curve for the diatomic, the upper band is always optical branch and the lower band is always the acoustic branch, and in between these two branches there is a one band which is not able to see any kind of the frequency within, and that is called the forbidden band. Any solutions for the vibrations pertain to the atomic equilibrium position or the wave solutions for the atomic vibrations or the lattice vibrations which cannot be resolved for this particular band or the region, and therefore you will find the waves are immediately damped off, it is not at all propagating, and therefore this band is referred as the forbidden gap or the forbidden band, which is lies in between under root of twice beta upon m2 to under root of twice beta upon m1 that we have seen in the last lecture. Now on this basis and on this grounds we will find it out some special cases and some important cases we will be discussing in today's lecture. So let us say do some special cases. In this case we have observed that let out of this two varieties of the masses what we have, that is m1 and m2. Let us say I do have a sodium crystal, sodium chloride crystals, then I do have one is Na atom and another is the Cl atom. One is a heavier atom and one is the lighter atom. So let m1 is a heavier compared to the atom m2. So in this case the vibrations achieved by each atom will be with different amplitudes, and if it is different amplitude, what it is, that we will see today. So if m1 is greater than the m2, in this case let us try to check it up the behavior of the wave or the equations near the smaller value of the k. So if k is tends to 0, that is what a low frequency, then the equation of the optical branch, that is omega plus square, this part is basically 4 sine square Ka. So sine Ka for a smaller value of the K, you can equate with the Ka. It is just like a sine theta is equivalent of a small theta, then sine theta is equal to theta. So same way sine Ka is equal to Ka. So sine square Ka is equal to Ka raised to square. So I am replacing in the equation the notation sine square Ka by k square a square, and since m is a heavier one, so denominator is heavier one. In addition to that, k is also very less, so entire the second factor of this square bracket is very futile contribution, so you can neglect it out. And in such situations your equation become like this, and neglecting that. If you look at minutely, this is whole raised to square raised to 1/2, and this factor becomes 0, then you can directly take a root, and it is just simply the repetition of the first factor, so it's just doubling of your first factor, so twice beta m1 plus m2 upon m1 into m2. This is the optical branch for the low frequency. In case of a one atom is heavier than the second atom, in present case the odd atom is heavier than the even atom. The same scenario you can think for the acoustic branch, and in the acoustic branch we are subtracting the frequencies. So while your first factor is subtracting by the certain factor, then we do have a common factor. Let us say we are taking off m1 plus m2, so this factor is in an inverted manner over here, so it's a 1 minus 4. Again the logic is that small value of the theta, and if sine function is there, so sine theta is equal to almost theta, so here it's a sine ka, so that is the same logic will be used here. The same logic will be used here. Only thing is this is minus, and this entire factor you are taking as a common, so beta into this factor, ये स्क्वायर है और यहाँ पे ओवरऑल 1/2 और द स्क्वायर रूट है, सो जब ये बाहर निकलेगा वो इट विल बी ओनली m1 plus m2 upon m1 into m2, oh, and this is become 1, and this is like this. So when you get a relation like this, you can solve it, and you can finally have the shape of equation like this. So the power is I am removing here by using the binomial function. So as you are knowing that it become 1 minus x, then it become 1 minus 1 by 2 factorial x square. So that logic will give me the relation something like this. So omega square with a acoustic branch is equal to, finally I do have the cancellation of m1 plus m2 with a m1 plus m2 raised to square, so 1 will go on, m1 into m1 m2 will get cancelled, so ultimately rest part will be twice of beta k square a square upon m1 plus m2. This is for the acoustical branch. Again for a low frequency, that means k tends to 0, as well as where m1 is heavier than the m2. Let us find it out some special outcome for the above calculation. The very first one, that in the diatomic cases we have received two varieties of the branches. One is acoustic and one is the optical branch, in contrast to the monoatomic lattice vibration, and therefore you can having a one is a upper branch which is referred as the optical branch, which having a little bit higher frequency value, and one is a lower branch which is referred as a acoustic branch. The second outcome, what we can find it out, the highest value of the acoustic branch, that is a twice beta upon m1, and the highest value of the acoustic branch, that is twice beta upon m2. I'm sorry, it's vice versa. The highest optical branch the lowest optical branch value at the first Brillouin zone, or at a pi by 2a, that is the under root of twice beta upon m2. This is the optical branch lower value, and the higher value of a acoustic branch at a k is equal to pi by 2a. so that would be twice beta upon m1 under root, and in between these two value there is a no solution does exist, and therefore this is known as the forbidden band for diatomic lattice vibrations. And in addition to that, we do have the question about the width of the band of this forbidden, so that naturally the width of this forbidden gap, because forbidden gap is lies in between these two square roots, so one can easily say that the forbidden gap is strongly depend on the value of masses of the each atom, that is a two different atom, then the mass of each atoms, as well as the spring constant or the force constant, and that will determine the gap of the elastic forbidden band in case of a lattice vibration. In addition to that, there is a one more outcome is possible, that since m1 is heavier than the m2, that is fine, but by chance you assume that m1 and m2 are equal, अगर दोनों का वेइंग सम है सेम है, माने आपका m1 weight is just equal to the m2, in such situations this 2b upon m1 is just equal to 2 beta upon m2, ये दोनों एक हो जाएंगे, and therefore you can say that the forbidden gap will be disappear, the forbidden gap will be disappear, and you can say that it is a merging of the two frequencies, acoustic branch and the optical branch. Okay, the third outcome is that what is the smallest wavelength can be possible within this acoustic or the optical branch, or rather let us say the first Brillouin zone, then naturally you can equate with the first Brillouin zone upper limit, that is a pi by 2a, you can equate with the k, so that is 2 pi by lambda, and it yields lambda is equal to 4a. Remember that lambda is equal to 4a, this is the minimal wavelength can be possible for the first Brillouin zone, with smaller than this it's not possible. Okay, so this is there. Now in the more detailed part we can also understand what is the optical branch and what is the acoustic branch. So let us try to understand that how particle is displaced in this particular two branches. दो ब्रांच है हमारे पास, acoustic and the optical. So let us take one by one. So the ratio of A1 and A2. A1 is the amplitude associated to the atom of mass m1, and A2 is the amplitude of the atom of the mass m2, and for this, that two set of equation of the previous lecture, that is a equation number 4 and 5, or you can say that the determinant equation, that equations you can modified, because here we are assuming that the k is tends to 0, and therefore in case of a optical branch, it become the k tends to 0 as well as the cos k tends to 0. So that two determinant equations which we had mentioned in the lecture number 5 as a equation number wait a minute, I am finding out the number for you guys, so it will be easy to understand for you people, and that equation number is 4 and 5. Yes, that I do remember, that what I said. Equation 4 and 5 will be rewritten as so this was the equation number 4, and that equation will be reduced to the equation twice of beta a1 minus a2 minus m1 a1 omega square. Cos ka is become 1. So ultimately omega square by twice beta is equal to a1 minus a2 upon m1 a1. Say this is equation number 2. Similarly, for k tends to 0 and cos ka is equal to 1, the another set of equation, that is the earlier one we had mentioned with the equation number 5, lecture number 5. So here this is this equation, and where now we are saying cos k is equal to 1. So if I substitute here as a cos k is equal to 1, so this another set of equation I can have, that is the omega square by twice of beta is equal to a2 minus a1 upon m2 a1. So just inverse of this, and the denominator will also change. If you look at minutely, the left hand side is identical, so you can compare the equation 2 and equation 4 with their RHS side, and from this we have received the equation a1 by a2 is equal to minus m2 upon m1, or a1 m1 is equal to a2 m2. This is a very interesting outcome over here, that as we have seen in the equation 5, that a1 m1, so amplitude associated to the mass m1 and their product is just with the negative sign when you are taking a product of a2 upon m2. इसका मतलब ये हुआ कि amplitude of atom 1, that is with the mass m1 or the odd number of atom, are just in the opposite direction of the amplitude with the even number of atom. माने सारे के सारे अगर NaCl की बात करें और NaCl में Cl हेवियर गिना जाए तो Cl odd नंबर पे आ रहा है और सोडियम इवन नंबर पे आ रहा है, तो सारे इवन नंबर के एटम एक तरफ आ जाएंगे जैसे कि डॉटेड लाइन में मैं बता रहा हूँ, और सारे ओड नंबर के एटम एक तरफ पे आ जाएंगे, एंड दैट वे यू हैविंग अ स्टैंडिंग वेव पैटर्न within this using these two particular different masses of the atoms within the crystals. So दिस इज़ अ वेरी स्पेशल ऑब्जर्वेशन इज ऑब्जर्व ओवर हियर. आप ध्यान से देख सकते हो कि A1 की डायरेक्शन और A2 की डायरेक्शन अलग अलग है. दैट नेगेटिव साइन इज अंडरस्टैंडेबल फॉर अस इन द डायरेक्शन ऑफ द प्रोपेगेशन. सो दिस इज़ अ वेरी special outcome we have derived. So in the further discussion we can think little bit about the acoustic branch. अभी ऑप्टिकल ब्रांच के लिए तो डिस्कशन ख़त्म हुआ. द सेम थिंग वी विल बी यूजिंग फॉर द एकोस्टिक ब्रांच. एकोस्टिक ब्रांच के लिए कैलकुलेशन करने से पता चला दैट यू कैन गो थ्रू दिस इक्वेशंस एंड इट्स वेरी स्मूथ इक्वेशन, not at all to worry at all, and finally you are able to get the a1 upon a2 is equal to 1. Now this equation is again very interesting equation, and that if I will take a denominator a2 on RHS, so it says that a1 is equal to a2. माने जितना एम्पलीट्यूड a1 का होता है उतना ही एम्पलीट्यूड a2 का होता है. माने अगर NaCl की मैं बात करूं तो जितना एकोस्टिक ब्रांच ऑफ NaCl में जितना वाइब्रेशंस m1 वाले मास ऑफ एटम ओड एटम का जितना वाइब्रेशंस और एम्पलीट्यूड हो रहा है उतना ही वाइब्रेशंस इवन पोजीशन एटम हैविंग द मास m2 के साथ होगा. एंड देयरफॉर इफ आई विल, दिस इज अ ट्रेंड लाइन आई हैव ड्रॉन इन माय PDF फाइल. So one is a hollow circle and one is a solid circle, alternatively they are situated. तो इसका मतलब ये हुआ कि they are vibrating in the same phase. And in the optical branch, both the atoms with a different masses are vibrating in a different phases. तो different phase माने 180 phase का variations है, और यहाँ पे they all are vibrating in a same phase. So that is the basic difference and outcome we have observed over here. it is an interesting one more thing, like wherever you having a two number of atoms, like a biprimitive cell, so primitive cell with the two atoms, or that is basically a non-primitive cell. Primitive cell mane there is only one atom within a unit cell, but if within the unit cell there is a two number of atoms, like a BCC, body centered cube, एक center में और 8 1/8 contribution on the corner, so two atoms. so अगर आपके पास दो एटम वाला structure है, then naturally you having a, in optical branch you having a the vibrations associated with the m1 and m2, mass of atom m1 and mass of atom m2 are vibrating in a anti-phase, and in acoustic branch they are vibrating in a same phase. दूसरी अगर बात सोचा जाए तो जैसे कि यहाँ पे दो एटम हमने डिफरेंट मास के लिए, तो हमने दो ब्रांचेस ऑब्जर्व की. सो सिमिलर टू दैट, सपोज आई डू हैव अ n नंबर ऑफ एटम्स with a different masses, then I do having a n number of branches within the lattice vibration crystal. So this is also the noticeable thing one has to remember. Okay, so this is fine. The next interesting outcome is that suppose I do have a m1 and m2 are equal, that means जितना मास m1 का है उतना ही मास m2 का है, और दोनों को मैं लेटर से स्मॉल m से डिफाइन कर दूँ, तो the equation variations of the frequency through which you are getting separate the, अगर ये समेशन करो तो ऑप्टिकल बन जाता है और सब्ट्रैक्शन करो तो एकॉस्टिक ब्रांच हो जाती है. वही इक्वेशन को मैं m1 m2 से जस्टिफाई करने लगूँ तो आई एम एबल टू गेट ओमेगा इज इक्वल टू ट्वाइस ऑफ अंडर रूट ऑफ बीटा स्मॉल m sin k a by 2. And in this case the maximum value of the omega, so I'm writing omega max, that is possible at a lower value of a k, because sin maximum is 1, so when k tends to 0 this become maximized, and it is written here for the maximum value sin k by 2 is equal to 1. So if it is 1, so your omega square maximum frequency will be equivalent of 4 beta upon m. अगर maximum frequency आपकी 4 beta upon m हो रहा है, then wait a minute, it is not highlighting, otherwise I can show you. Okay, so this is there. So this range of a frequency is 0, so omega square is lies in between 0 to 4 beta upon m. फिर से याद दे रहा हूँ, some interesting facts we are finding out for the diatomic lattice, and that is how we can say that diatomic cases, and in case of a diatomic cases the frequency will be in the range of omega omega square is lies in between 0 to 4 beta m. Okay, so the next is m1 और m2 इक्वल होने की वजह से आपका फॉरबिडन गैप तो डिमिनिश हो गया, राइट. But now the interesting part, the how the frequency range will be identified. That means 0 से exact half value 4 beta by m का half value कर दो, so it become a twice beta upon m. So that would be your acoustic branch, because it's a lower range of a frequency, and higher range of a frequency is a twice beta upon m, lies in between 4 beta upon m, so that become your optical branch. So that is a fact outcome number 1. Second one is for, let us say, heavier mass of a m1 compared to the m2, that is already we have seen rather, but let us put it in the different way, that if m1 is higher, then the optical branch lower limit or the upper limit of the forbidden gap, that is the under root of twice beta m1 will decreases, right. So that means optical branch will come uh, closer to the acoustic branch, and it is written, I think so, the acoustic branch is downward compared to the optical branch, which is like omega plus is equal to under root of twice beta upon m1 plus m2 upon m1 m2, and where the m1 is heavier, if m1 is heavier, so upper one, the addition of m2 to m1 is not changing a lot, so this is almost bracket is remain equivalent to m1, so the upper m1 and lower m1 will get cancelled and it become the under root of twice beta upon m2. So this is optical branch where the m1 is the heavier. एंड इन द एक्सट्रीम केस अगर m1 बहुत ही भारी है और वहाँ इट इज़ लेस लाइक ए इनफाइनाइट कंपेयर टू द infinite compared to the mass of even atom, then you will be observed that the omega माइनस दैट इज acoustic branch is almost 10 to 0. तो इसका मतलब ये हुआ कि acoustic branch will get diminish, acoustic branch will get diminish. So that is very much interesting. Let me repeat again over here about the situation that if m1 is heavier, then it is under root of twice beta m1 is with a very small value, and basically this is the upper limit of acoustic branch. I think earlier I had told you wrong thing. So under root of twice beta m1, this is referred as it is not getting highlighted. This is under root of twice beta m1 is the upper limit of the acoustic branch. You can just keep the optical branch and acoustic branch graph in front of you, or the dispersive curve in front of you, so you can enjoy that part. So this will be suppressing as the m1 will be larger, okay, and the optical branch is not affected by the m1 heavier and so on. But as the heaviness is still larger, so m1 अगर आप बहुत ही heavy infinite गिन लो तो outcome value will be 1 over infinite will be tends to 0, and therefore acoustic branch will be diminished. So in this case, in such case, you can say that the disappear of completely about the acoustic branch. So acoustic branch will can get disappeared. अगर वो disappeared हो जाता है तो आपको acoustic branch मिल ही नहीं रही है. At the same time, optical branch, instead of that wavy nature, it become the flatten off. So why it become a flat off? Because there it is mentioned here that it become the under root of twice beta upon m2, that is remain constant. वो constant value हो जाती है. acoustic branch में variations amplitude नहीं दिखते हैं because of this variation, क्योंकि m1 plus m2 तो m2 का कोई contribution ही नहीं रहा, सॉरी m1 का कोई heavier होने की वजह से it's almost like a stagnant, and therefore you can say that it looks like a constant. So the dispersive behavior curve, that is omega versus k, it looks like a very much two straight lines. Am I clear with this? And the interesting point regarding this knot is the physical meaning over here is that each lattice is completely free and unaffected by the negligible variations. So this is a physical meaning of this, that it is unaffected by the neighbors or oscillating with the natural frequency. तो यहाँ पे जो फ्रीक्वेंसी आपको वाइब्रेशन देगी, ये ऑप्टिकल ब्रांच या एकॉस्टिक ब्रांच तो चलो सप्रेस हो गई, और ये भी फ्लैटन ऑफ हो गई, तो यहाँ पे वाइब्रेशन नहीं है ऐसे तो नहीं बोल सकते, बट दे आर ऑलमोस्ट वाइब्रेटिंग विद देयर natural frequency, because one is very heavier and one is very light, so their individual contributions are almost freezed out. Okay, so you can say that they are almost unaffected by the neighboring oscillation and so on. Okay, so that is second outcome. The binomial function is just for your reference. If m1 इज़ नॉट इक्वल टू इनफाइनाइट, अभी हमने एक केस लिया कि m1 इनफाइनाइट होने की वजह से एकॉस्टिक ब्रांच सप्रेस हो सकती है. सो अगर m1 इज़ नॉट इक्वल टू इनफाइनाइट but still it is a heavier, the isolation of the each atom is removed and a two different frequency will be reappears. Okay, अगर वो heaviness नहीं है then you can definitely having the two branches. As the lighter mass of the m2, अगर एक m2 is lighter and m1 is heavier, तो दूसरे पॉइंट ऑफ व्यू से अगर देखा जाए तो ऑप्टिकल ब्रांच, सो दैट इज़ under root of twice beta upon m2, that is a lower limit of the optical branch or the upper limit of a forbidden gap, that will increases. सो आप ये बोल सकते हो कि एकॉस्टिक ब्रांच और ऑप्टिकल ब्रांच के बीच का डिस्टेंस बढ़ जाएगा, और द लार्जर साइज ऑफ द फॉरबिडन गैप एंड शिफ्ट ऑप्टिकल ब्रांच लिटिल बिट अपवर्ड. ओके, तो दूसरा पॉइंट और तीसरा पॉइंट यहाँ पे ये हो रहा है कि m1 हेवियर है तो एकॉस्टिक ब्रांच सप्रेस हो रही है, अगर m2 लाइटर है तो ऑप्टिकल ब्रांच अपवर्ड डायरेक्शन में शिफ्ट हो रही है. दैट इज सेकंड नोट पॉइंट वी हैव ऑब्जर्व. अगर दोनों इक्वल है तो फॉरबिडन गैप डिसअपियर हो रहा है, एंड द फ्रीक्वेंसी रेंज इज स्टार्ट बिटवीन 0 टू ट्वाइस बीटा अपॉन m एंड ट्वाइस बीटा अपॉन m से लेके 4 बीटा अपॉन m तक की एकॉस्टिक ब्रांच हो जाएगी. सो दैट इज देयर. The fourth okay, the third outcome we have said that okay, the branch get upward. In the extreme cases, मान लो कि m2 is very much light and negligible, so माने m tends to 0 अगर मैं गिन लूँ तो ये चीज़ हो जाएगी इनफाइनाइट. सो इन दैट केस ऑप्टिकल ब्रांच बिकम डिसअपियर. अगर ऑप्टिकल ब्रांच डिसअपियर हो रही है तो आप बोल सकते हो इट इज़ ऑलमोस्ट लाइक द केस ऑफ मोनोएटमिक लेटिस वाइब्रेशन. सो अगर m2 टेंस टू 0 आप सोच रहे हो तो इन दिस केस it is similar to the case of a monoatomic lattice vibration with the twice of lattice constant. The fourth outcome which is very interesting, and that is the theory shows that the frequency band is a periodic structures. Okay, so theory shows that the frequency band in the periodic structure, if the atom per primitive unit cell is splits into the two bands. I think I have already covered up this point in the beginning part कि अगर दो एटम है तो दो बैंड मिल रहे हैं, तो तीन एटम है तो तीन बैंड मिलने चाहिए, चार एटम है तो चार. सो दैट वे इफ़ आई डू हैव n number of atoms, then I should having a n number of the bands of the frequency. So this is also the interesting point over here. The last point and interesting variations that suppose मैं डिस्पर्सिव रिलेशन की जगह a1 अपॉन a2 वर्सेस k का ग्राफ ड्रॉ कर रहा हूँ फॉर द अनइक्वल मासेस वेयर आई कैन से द m1 is a heavier than the m2, then what I have observed toward the first billion limits, that is pi by upon 2a minus and plus value of the k, then acoustic branch is become the infinite and become move upward, whereas the optical branch is suppressed and it become a negative at the lower value of the frequency. At the higher value of the frequency they will just diminish off. So this is very interesting and very special thing you can observe. How you can observe? By taking the ratio that a1 m1 is equal to a2 m2 with the negative or the opposite direction. अगर a2 राइट, फिर से मैं थोड़ा बता दूँ आपको कि अगर m1 हेवियर है तो a1 is almost at a rest, तो एम्पलीट्यूड एसोसिएटेड टू a1 विल बी 0. तो ये इक्वेशन में लेफ्ट साइड बिकम अ 0, so numerator of this become a 0. So you can say that a1 at the rest in the optical branch. So कहाँ पे ये रेस्ट करेगा? जब पाई बाई 2a है तो आपकी ऑप्टिकल ब्रांच become 0 at the edge point. Am I clear with this? Okay. And second one is let us say a1 upon a2 is equal to minus m2 upon m1. In this case suppose आप ये बता रहे हो कि m1 is a heavier, so sorry, yeah, m1 is a heavier, so m1 is a heavier, तो यहाँ पे m heavier हुआ तो 1 over this is m1 is heavier, very high, so very high, so this is almost like a wait a minute, the optical branch where whereas in the acoustic branch, okay, whereas in the acoustic branch it's a1 upon a2 is equal to minus m2 upon m1, and this become the infinite. Why it become the infinite? Because a2 is now almost 0, a2 is equal to almost 0. Okay, the reason is m2 will be at a rest, the m2 will be at the rest. So अगर m2 माने मास एटम is 0, so यहाँ पे 0 आ जाएगा और यहाँ पे 0 आ जाएगा, तो a2 is become the 0. So this is the another way of understanding that stated that the first Brillouin zone in any branches, one of the sublattice is only vibrating. So अगर दो मास में हेवियर है, एक दो एटम में से एक हेवियर है या तो एक लाइटर है, तो दो लेटिस में से, दो सब लेटिस में से एक लेटिस ऑलवेज वाइब्रेटिंग रहेगा. सो दैट विद दिस I think all the outcome is finished. Thank you so much for paying attention. Stay home, stay safe.